Namaste dosto, welcome to the channel. Today we're diving deep into the world of computers, but not in the way you might think. We're not talking about processors or graphics cards, we're talking about the language computers use, number systems. You might be thinking, number systems? That sounds boring, but trust me, this is the foundation of everything your computer does. We're going to break down the four main number systems. Binary, the language of zeros and ones that makes your computer tick. Decimal, the system we use every day that's surprisingly important in computing. Octal, a blast from the past that still has some relevance today. And hexadecimal, the system that's all about efficiency, especially in programming. So, buckle up, hit that subscribe button and get ready to unlock the secrets of how computers understand the world, one digit at a time. Let's kick things off with the big one, binary. This is it, the core of how computers process information. Imagine a light switch. It can be either on or off, right? That's binary in a nutshell. 1 for on, 0 for off. Now, imagine millions, billions of these switches flipping on and off at lightning speed, and that's how your computer thinks. Every image you see, every song you listen to, every video you watch, it's all just a series of ones and zeros to your computer. Think about that for a second. It's pretty mind-blowing, but how do we get from a simple 1 or 0 to representing complex things like letters, colors, or even entire operating systems? Well, it's all about combinations. Just like we use the digits 0 through 9 in different combinations to create any number, binary uses ones and zeros. Each digit in a binary number is called a bit, and 8 bits make up a byte. The more bits you have, the more combinations you can create, and the more complex the information you can represent. So, when you hear people talking about 32-bit or 64-bit processors, they're talking about how many bits the processor can handle at a time. More bits mean more processing power, which translates to faster and more capable computers. Pretty cool, right? Now let's talk about the number system we use every day, decimal. Seems pretty basic, right? 0 through 9, what's the big deal? Well, even though computers think in binary, they still need to interact with us humans, and we use decimal. This is where things get interesting because computers need a way to convert between these two systems. Think of it like translating between two languages. Luckily, computers are really good at math, and converting between binary and decimal is just a matter of some clever calculations. Each digit in a decimal number represents a power of 10. For example, the number 255 is really 2 times 10 to the power of 2, plus 5 times 10 to the power of 1, plus 5 times 10 to the power of 0. Binary works the same way, but with powers of 2 instead of 10. Understanding how decimal relates to binary helps us understand how computers process the information we input using keyboards, mice, and touchscreens. It's the bridge between our world and the digital world. Chapter 3. Octal number system, एक पुरानी लेकिन महत्वपूर्ण प्रणाली. Next up, we have octal, the number system that uses digits 0 through 7. You might not come across octal as often as binary or decimal, but it still pops up in computer science, especially when we're talking about older systems. Octal was more common in early computing because it provided a more compact way to represent binary numbers. Remember how we talked about bits and bytes? Well, octal groups those bits into sets of 3, making it easier for humans to read and write long binary strings. Think of it like this. If binary is like speaking directly to a computer in its native tongue, then octal is like using a simplified code that's easier for both humans and computers to understand. While octal isn't as widely used today, it's a great example of how we've constantly been finding ways to make computers more efficient and easier to work with. Chapter 4. Hexadecimal number system, programming or rung coding ka raja. Last but not least, we have hexadecimal, often shortened to hex. This is the number system that uses digits 0 through 9 and letters A through F to represent values. Now, I know what you're thinking. Letters in a number system, that seems strange. But trust me, it makes a lot of sense. Hexadecimal is all about efficiency. It lets us represent large binary numbers using fewer digits, which is really helpful in programming and web development. For example, have you ever noticed those 6-digit codes used to represent colors on websites? Those codes are in hexadecimal. Each pair of digits represents the red, green, and blue values of a color, allowing for millions of color combinations. So, even though it might seem a bit intimidating at first, hexadecimal is a powerful tool that unlocks a whole new level of control and precision in the digital world. Outro संख्या पद्धतियों की दुनिया अन्वेषण समाप्त. So, there you have it, a journey through the fascinating world of number systems in computers. We started with the fundamental binary, the language of computers, and explored how it connects to the decimal system we use every day. Then we took a trip down memory lane with octal, and finally, we unlocked the power of hexadecimal. Understanding these different number systems gives you a whole new appreciation for how computers work at their core. It's like peeking behind the curtain and seeing the magic that makes all of this technology possible. Thanks for joining me on this adventure, and don't forget to hit that like button and subscribe for more deep dives into the world of tech. Until next time, keep exploring.